Today we're going to learn factoring sum and difference of two cubes. The questions were sent to us by Crispo from Las Piñas National High School. If you remember, last month we awarded Las Piñas National High School as the first place winner for our back-to-school video contest in public and private schools in the Philippines. Again, congratulations to Las Piñas National High School. Factoring sum and difference of two cubes is not difficult, but make sure that you remember these patterns. Sum of cubes is in the expression of the form a cube plus b cube. And if you have that format, this sum of cubes can be factored as binomial a plus b and the trinomial a squared minus ab plus b squared. For the difference of cubes, a cube minus b cube, that can be factored out as a binomial a minus b and a trinomial a squared plus ab plus b squared. Take note here that if you have sum of cubes a cube plus b cube, the binomial is also a plus sign. For the difference of cubes a cube minus b cube, the binomial is also a minus. And to find the trinomial, we will be using the binomial. So for example, if you have a plus b, the first thing that we need to do for a plus b is square the first term, which is a square. You multiply a and b, which is ab, but it has to be the opposite sign. And third, square the second term b, so you have b squared. The same thing from the given a minus b, square the first term, so we have a squared. You multiply a and negative b, that's negative ab, but we need to take the opposite sign. And third, square the negative b, and that is b squared. So the factors are always binomial and a trinomial. Let's try these 6 examples. Completely factor the following expressions. Let's begin with question number 1, a cube minus 64. The first thing that we need to do for this is rewrite it as a difference of two cubes. We have a cube minus 64 is the same thing as 4 to the third power. 4 times 4 is 16, 16 times 4 is 64. From this difference of two cubes, we can easily find the binomial. The binomial is a minus 4. You simply write down the a here and the b here. So again, the binomial is a minus 4. Now let's find the trinomial. For the trinomial, we have 3 steps. The first step is to square the first term, that is a squared. Next, we need to multiply a and negative 4, that's negative 4a, but we need to take the opposite sign, that should be plus 4a. And the third term, we need to square the negative 4, so negative 4 times negative 4 is positive 16. So the complete factors of a cubed minus 64 is a minus 4 times a squared plus 4a plus 16. Question number 2, 8m cubed minus 1. First, we need to write this as a difference of two cubes. 8 is a perfect cube, so we will write it as 2m to the third power. Because 2m times 2m is 4m squared. 4m squared times 2m, that gives you 8m cubed. And of course, 1 is a perfect cube, which is minus 1 to the third power. Negative 1 times negative 1 is positive 1, times negative 1 is negative 1. So now, what do you think is the binomial? The binomial is the first term 2m and the second term minus 1. What do you think is a trinomial? The first term is the square of 2m. So 2m times 2m is 4m squared. The second term, you multiply 2m times negative 1. That's negative 2m, but take the opposite sign, and that is plus 2m. And finally, square negative 1, and that gives us plus 1. So the complete factors of 8m cubed minus 1 is 2m minus 1 times 4m squared plus 2m plus 1. Question number 3. X to the 6 plus 125. Now we will write this as sum of two cubes. X to the 6 is the same thing as x squared to the third power using the laws of exponents. X squared times x squared is x to the fourth times x squared, you have x to the 6. 125 is also a perfect cube, and that is 5 to the third power. 5 times 5 is 25, times 5 is 125. So again, the factors will be a binomial and a trinomial. It is a sum of two cubes, so the binomial should be a plus. And that will be the first term x squared and the second term plus 5. What do you think is the trinomial? First term, we need to square x to the second, so that is x to the fourth because x squared times x squared is x to the fourth. Next, we need to multiply the first term and the second term. So x squared times 5 is 5x squared, but we need to take the opposite sign, so minus 5x squared. And finally, square the second term, that's 5 squared, so we have plus 25. Question number 4. B cubed plus 1000 C cubed. Is 1000 a perfect cube? Yes, it is. That's 10 to the third power. 10 times 10 is 100. 100 times 10 is 1000. So number 4 can be rewritten as b to the third power plus 10c to the third power. 10c times 10c times 10c is 1000 c to the third power. And again, we will have a binomial that is plus, and we will have a trinomial. So the binomial is the first term b, and the second term, that's 10c. So the binomial is b plus 10c. For the trinomial, we square the first term b, so that's b squared. Next, we will multiply b times 10c, that's 10bc, but we need to write negative, the opposite, so minus 10bc. And lastly, square the second term 10c. 10c times 10c is 100c squared. So the factors of b cubed plus 1000c cubed is b plus 10c and b squared minus 10bc plus 100c squared. Question number 5. 27 n to the 6 minus 343 p to the third. 27 is a perfect cube, and that is 3 to the third power. 343 is a perfect cube as well, which is 7. 7 times 7 is 49. 49 times 7 is 343. It is really important that you know your perfect cubes to make it easier in factoring sum and difference of two cubes. So for question number 5, we can rewrite this as 3n squared to the third power. 3 to the third is 27. N squared to the third is n to the 6. The second term, we can write this as minus 7p to the third power. 7p times 7p is 49p squared. Times 7p, you have 343p to the third power. So for the binomial, we will have the first term 3n squared, the second term minus 7p. Now let's get the trinomial. First, we need to square 3n squared. 3n square is 9n to the 4th power. Next, we need to multiply 3n squared times negative 7p, but take the opposite sign, so that to be positive. 3 times 7 is 21, and we will write down the variables n squared and p. The last term, square the second term, negative 7p, so that is 49p squared. So the complete factors are 3n squared minus 7p, and 9n to the 4th plus 21n squared p plus 49p squared. Question number 6. What do you notice here? 5 and 40 are not perfect cubes. But for question number 6, this expression has a GCF, or the greatest common factor. What do you think is the GCF for this problem? The GCF here is 5a. So if we factor out the 5a, inside the parentheses, we will have a to the 3rd power. Because 5a times a to the 3rd is 5a to the 4th power. Now, what will you multiply with 5a to get 40a? It's 8, right? So that problem is the same thing as 5a times a cubed plus 8. And we can still factor out a cubed plus 8 because that is also a sum of 2 cubes. So this problem is the same thing as 5a times a cubed plus 2 to the 3rd power. So simplifying this further, we have 5a, and then we have a binomial, and we have a trinomial. So for the binomial, it's the first term a and the second term 2. For the trinomial, we need to square a, that's a squared. We multiply 2 and a, that's 2a, but we need to take the opposite sign, so minus 2a. And square the second term, that is plus 4. So the complete factors of 5a to the 4th plus 40a is 5a times the quantity a plus 2 times the quantity a squared minus 2a plus 4. Thank you for watching, and please consider subscribing to my channel at Celzo Academy.